Section 3.1, ready, set, go. We're going to focus on number 3, and then we'll talk about the section 7 through 10 or 11, but we'll focus on number 7. So the first problem here, number 3, says, graph each of the functions, name 3 points that lie on each graph, choose a scale for your graph that will make it possible to graph your 3 chosen points. You have a couple ways to approach this. You can graph it. You can go to desmos.com and you can type in the function and graph it and see what it looks like, but you got to put it on the graph they gave us, so you got to figure out the scaling. What I would do maybe is find the 3 chosen points. Find 3 points, to graph it on here, and use those points to help you dictate how you're going to scale and graph this function. Now, first off, the problem h of x equals 5 times 3 to the x, that's exponential. You started with 5, you're multiplying by 3 over and over and over again. That's why it's 3 to the x power. Okay, the x is the exponent, shows me exponential. Excuse me. So I'm going to make a little table. I'm going to plug in x, and I'm going to output h of x. So start with 0. You could use negative 1 if you want to. Okay, so I'll start with 0. I'm going to have 5 times 3 to the 0 power. Now anything to the 0 power is 1. 3 to the 0 power is 1. So 5 times 1 is just 5. That's my output. So my first point is 0, 5. Let's plug in 1. 5 times 3 to the first power. I have, 3 to the first power is 3, and 5 times 3 is 15. My second point is 1, 15. Now I'm going to plug in 2. 5 times 3 to the second power. 3 squared is 9. 5 times 9 is 45. You can choose any values of x you want. I could use decimals. I could use fractions. It doesn't matter. This is an exponential function. There's no context. Therefore, it's going to be continuous. So I can plug in any number I want. So I have my points. Okay, the points are 0, 5, 1, 15, 2, 45. So for my graph, I have to be able to fit those on it. So I'm going to make a graph here. Let's go, 0 is the smallest x, and 5 is the smallest y I have. So I can probably put my x-axis down here. And my y-axis, I'll go ahead and put it right here. But I can probably put it a little bit further over if I want to. So I'm going to label those. Here's my x-axis. Here's my, I have no idea what just happened there. So let's go back. Cool. I know what I did. So this is the x-axis. This is the y-axis. And I'm going to plot my points. Well, I can't plot them yet. Let's create tick marks here. I'll do those in blue. So move this over. I'm going to have my x-axis go by 1s. So my tick marks, I don't really need to draw them in, but I'm doing it just to show you that this is 1, 2, 3, 4, 5, 6. My y-axis, however, that's the tricky one. The biggest y value I have right here is 45. So I have to be able to go at least up 45. So if I go by 5s, 5, 10, 15, 20, 25, 30, 35, 40. 45 will put me at the very top up here. This would be 45. So I can go ahead and go by 5s. I'm just going to put that on there. I've scaled it. My x-axis is going by 1s. My y-axis is going by 5s. So let's plug in. I'll do this part in red. 0, 5 over 0 up 5. That's my y-intercept. According to the function, I started at 5. Perfect. The 0th number is 5. That was easy. 1, 15. Over 1 up 5, 10, 15. 2, 45. Over 2 up 45. I'm connecting these. You can see they're curving, and this would keep going up. Now, if I were to plug in negative numbers, like -1, okay, I'd end up going this way, and it would flatten out almost. It would never cross the x-axis. It's exponential. It curves exponentially. It gets bigger and bigger and bigger. But if I'm going the other direction on the x-axis, it gets smaller and smaller and smaller and closer to 0, but it never actually crosses the x-axis. It looks like it flattens out. And you could Desmos this function, and you can zoom way out and see that. So my 3 points, I'll just list them down here. 0, 5, 1, 15, and 2, 45. I could come up with way more than that, but only ask for 3. There they are. And for this problem, when you're working with the linear ones, when you're working with problems 1 and 2, approach the same way. You can either graph it first, or you can come up with 3 points by making a little table, plotting them, help you decide how to scale it. All right, we're going to look at problem number 7. However, this is a matching problem, so I'm going to show you the whole problem. It says, for each graph given, match it to the contextual description that fits it best. Then label the independent and dependent axis with the proper variables. Independent and dependent. X-axis is my independent, because the x is just whatever x is. It doesn't depend on anything. The y-axis is my dependent variable. Okay, the y is the dependent variable because y depends on what x is. Whatever you plug in for x, that's what's going to give you y. So y depends on x. So independent is x, dependent is y. Independent is my input, dependent is my output. So what I'm going to do before I actually do number 7 is I'm just going to read through the contextual descriptions and decide if they're continuous or discrete. Because I can see in the graphs which one's continuous and discrete. 7 is continuous, 8 is continuous, 9 is discrete, 10 is discrete, 11 is continuous. So when I look at the context here, it says the amount of money. So context A, the amount of money in a savings account with regular deposits and some withdrawals. So you're just going to have whatever amount of money's in there, and then you're going to deposit, and you're going to have more, and you're going to deposit and have more. So I would say this is discrete. Okay. B, the temperature of the oven over on a day that mom bakes several batches of cookies. The oven's temperature will just kind of rise and fall depending on if you're baking cookies or turning the oven off, but this is continuous because at any moment in time I can see what the temperature is, whether it's higher or lower. Problem C, the amount of gasoline on hand at the gas station before the tanker truck delivers more. This one's continuous because it's gas, and gas is a liquid. You can see how much there is, whether you're putting more in or taking more out. Part D, watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons available on sale on Thursday. This is discrete. It's watermelons. I'm not going to be selling little chunks of watermelons, or I'm not going to grind it up and be pouring it out as a liquid, so it's discrete. There's a whole watermelon at a time. E, the amount of mileage recorded on the odometer of a delivery truck over a time period. Mileage is continuous because I can see how much mileage I have at any moment in time. So I look at this and I see that there's 1, 2, 3 of them that are continuous, and over here there's 1, 2, 3 of them that are continuous and 2 that are discrete. Okay, so that helps me. I can kind of see which ones I'm going to match to. Now we're focusing on number 7 here. Okay, number 7 says, well, actually it shows a graph where you have this line that's continuous, that first it increases a decent amount, and then it kind of is like high and then low and then high and then low, and then it's going up and then down, but it never goes any higher or any lower until the very end. So this to me makes me think of, which one is it? B. Okay, this makes me think of B right here, because temperature of oven on a day that mom bakes several batches of cookies. Well, the temperature of the oven is nothing, okay, and or whatever it is, say it's 50 degrees, 60, 70 degrees, and then you turn the oven on and it increases to 425 for the cookies, and you turn it off. Well, you wait for the next batch, then you put the next batch in and turn it on again, and it heats back up and down. The oven just increases and decreases as you make batches of cookies. And then you turn the oven off, and it decreases back to whatever the room temperature for the oven. Okay, so 7 would, the answer would be B. And I'm going to erase these so you don't get confused and think those are the answers. They're not. That was just me saying continuous or discrete. So I'm going to get rid of those. So that's how I do all those problems. Okay. Good luck. We'll go over those in class.